Dear students, I am Dr. Ramneet Kaur from Post-Graduation Department of Physics, Mata Gujri College, Fatehgarh Sahib. Today we are going to discuss the experiment that is reverse biasing characteristics of Zener Diode. First of all, I will give you the introduction to small theory by using a PowerPoint presentation. Then we will move directly to our physics laboratory where we will perform the experiment on the kit.
So today we are going to discuss Zener diode. The aim of the experiment is to study the reverse bias characteristics of Zener diode. So first of all, let us discuss what actually the Zener diode is. Zener diode is a silicon PN junction diode, but it is different from the ordinary diode because it is heavily doped and it operates in reverse breakdown region. The breakdown voltage is entirely dependent upon the level of doping during the manufacturing. So these are the symbolic representations for the Zener diode. The first is the physical symbol. The red portion represents the anode part, that we can say in the triangular part, that is the positive part, and the negative part is represented by the cathode. The below figure represents the P part and the N part semiconductor. The central region is the depletion region. As we discussed that the PN junction diode is reverse biased. Due to reverse biasing, the depletion width has greater area as compared to the forward biasing. So this is the circuit diagram for the Zener diode. So this is the positive terminal which is connected to the negative terminal of the unregulated DC voltage, and the negative terminal is connected to the positive terminal. So the Zener diode is reverse biased. RS represents the source resistance and RL is the load resistance. The I is the amount of current flowing through the source resistance RS. IZ is the Zener current. IL is the load current. So typically the main application of this circuit is that we will get the stable reference voltage as an output. At that breakdown voltage, the current increases at a particular breakdown value. Now, this is the VI characteristics of the Zener diode. This characteristic can be divided into two parts. The first is the forward bias region and the second is the reverse bias region. During the forward bias region, we have same kind of graph as we have during the PN junction diode. So, in the forward bias region, the voltage is positive. So, we have connected P terminal of the battery to the P side of the diode and N terminal of the battery to the N side of the diode. So, initially, when we increase the voltage, we don't have any current value. Further, with slight increase in voltage up to 0.3 to 0.7 volt, the current starts increasing linearly. This particular voltage at which the current starts increasing linearly is called the knee voltage. And the second portion is the reverse biasing. So during the reverse biasing, what we have negative voltage connected to the Zener diode, and initially the value of current is very low, almost it's nearly zero. We will verify this particular thing on our experimental kit. When further voltage value is increased at a particular Zener breakdown region, the current starts increasing abruptly. This value at which the current starts increasing abruptly is called Zener breakdown region. For every diode, this Zener breakdown voltage is the voltage at which the diode works as a voltage regulator. As we shown in the circuit, Zener diode is reverse biased. First of all, we are giving the connections of the power supply to the voltmeter. I have connected positive of the output voltage to the positive terminal of the voltmeter. Now I am connecting negative to the negative of the voltmeter. Next task is to introduce the ammeter in the circuit. Ammeter is supposed to be connected in series connection. So I have connected positive of the ammeter to the positive terminal of the diode. Negative terminal of the ammeter is connected to the one terminal of the source resistance. Here the source resistance is 1K only. Then we have connected negative terminal of the ammeter at the negative of the voltage. Then only one connection is left, that is to connect the RS to the output power supply at a positive terminal. So here we finish up with our circuit. So the voltmeter is connected in the parallel, ammeter and the source resistance Rs are connected in series. Here in this circuit a knob is provided in which on the upper portion 15 milliampere is written and on the bottom portion it is 150 microampere. If you connect your Zener diode in the forward bias, then you will adjust this particular knob at 15 milliampere because we know that in case of in a forward biasing, the current value is high. So we will connect it in 15 milliampere, while in reverse biasing, the value is low. So we use the units that is microampere, that is 150 microampere. The current value in reverse bias is less because depletion width increases due to the reverse biasing. Slowly, so you can see that the current value is not increasing at all. It is still 0 microampere. Although my voltage value has reached 5 volt, on further increasing up to 7.5, I don't find any change in the current value. After 7.5, the current has increased abruptly. At 7.75, the current has increased abruptly. This particular voltage is the Zener breakdown voltage, after which the current shows a sharp increase at a fixed value. So this particular characteristic curve gives us the use of Zener diode as a voltage regulator device. So, after going through the experimental kit, let us have a quick view on some viva questions which may be asked to you during your practical examination. The main question is this: what is the difference between ordinary PN junction diode and the Zener diode? So the answer is that the difference is at the doping level. Zener diode is heavily doped as compared to PN junction. The second question, how Zener diode is biased? This is very important question. The Zener diode is reverse biased. The third question, what are the applications of Zener diode? Zener diode acts as a voltage regulator, increasing current at constant reverse voltage. The fourth question, explain knee voltage. Knee voltage comes in the picture when the Zener diode is forward biased. At this particular knee voltage, current starts increasing linearly with further increase in voltage. The fifth question, what do you mean by breakdown voltage? Breakdown voltage occurs during the reverse biasing, so the current increases abruptly with small change in the reverse voltage.
I hope this video will be helpful to you for understanding the concept. Keep watching for more information. Thank you.